Okay, so 7.12, school bus of this mass, guys. Thank you. Of this mass, which means it has that much inertia, and it moves at 10 meters per second. How fast must this baseball move in order to have the same momentum as the bus? Okay, so it's about momentum. So when let's see, 7.12, right? It's problem 7.12. And it has to do with momentum, so it'd be good in my Y to show that I understand what momentum is. Anybody give me what their understanding of momentum is? What you got, Molly? Say it again. It's a good start. It's a good start. I like that. The quantity of motion that objects have. What else it ties in there, though? It's not only motion, it's one other thing. You guys can just talk, by the way. Thank you for raising your hand. Inertia. So, I would say, quantity or amount of motion and inertia. An object has is momentum. And some people might, you can phrase it however you want. Some people might say that momentum is inertia in motion and motion, or take into account. So that's a good showing that you understand the physics. Now, one thing you should always think about is what is unique, or what can I say unique about this problem? How do you guys think the velocity of the baseball is going to compare to the velocity of the school bus, given their inertias? Which one do you think is going to be more? Are they going to, well, I guess three options. One's going to be more, or they're going to be the same. What do you think? Yes, interesting ceiling, isn't it? Amazing how many eyes went. Don't call on me. What do you think? How's the velocity of the baseball, given its inertia, going to compare to the velocity of the school bus? Is it going to be more, less, or the same? What do you think? Way more? What do you think?
I had an answer, but I think I was smart.
It's okay. What was your answer? How do you think the velocity of the baseball is going to compare to the velocity of the bus? Is it going to be more, same, or less?
And velocity includes.
No, velocity is how fast you're moving in what direction. You're going to agree way more. Okay. What other opinions do we have? None? Oh, come on, be risky. Take an opinion. You're going to think it's going to be more? Okay. It does. It says 10 meters per second. Right? Still think it's going to be faster. Okay. Faster or way faster? Okay, that's fair.
I'm going faster.
You're going to faster, not way faster?
Way faster. Because the school bus, the formula for momentum, inertia times velocity, right?
Yeah, I haven't gotten there yet. But, yeah.
So, if the school bus weighs,
We don't know the weight. We know the inertia.
and velocity is kind of slow. But when you multiply those numbers together, so to equal that same really big number, the baseball is going to have to stop.
Ludicrous. We've gone from way fast to ludicrous. Ludicrous speed. What do you guys think? faster? Okay. Good. If you didn't have an opinion, think of an opinion. All right. So now you would I would actually add to my y now, make it specific to this problem. I would add in that opinion. So I'm going to say the ball will, oops, that was supposed to be traveling. By traveling, I mean velocity. I'm going to say much faster. Some of you might put way faster or ludicrously faster or just faster. All right, I'm going to go with much, just because. So that would be a y that on this problem earned full credit. If I look at my rubric, it shows my understanding. It tells me why the universe works this way, not how. And it also kind of sketches out my map that I think that the ball is going to be moving way faster or much faster. So I'm going to be looking for an answer that's much bigger than 10 meters per second. If I get an answer of 2, I'm not going to be happy. I'm going to make sure I did everything correct. All right? So now I can switch over to my more traditional side here of doing the math, showing it again, but with mathematics. And it's about momentum. So it would be good to have my momentum equation, which here's our equation sheet, and we can grab our momentum equation. That's momentum is the inertia multiplied by the velocity. And nicely that comes right in. That also satisfies, right, the first part of my how rubric, right? So start with valid physics equation. You guys all have that rubric, right? Yes? All right, good. And I'm going on here, let's see. So the problem wanted the momentum of the bus and the momentum of the baseball to be the same. So if I say the momentum of the bus, that must be the same as the momentum of the ball. That, and then I substitute in for that momentum, I substitute in the inertia of the bus multiplied by the velocity of the bus. This is where I'm using my equation, my relationship here. And that must equal the inertia of the ball and the velocity of the ball, right? And now it's plugging in my values. One thing that's always good to look at when you're doing this is just looking to make sure, okay, my answer is going to be in meters per second. So I have a velocity in meters per second. Good, I don't need to convert them. Kilograms and kilograms, so everything's nicely in my base units of kilograms, meters, seconds, things like that. So I can just straight substitute in. I don't have to do any mathematical conversion. So for the inertia of the bus, that's my 18,200 kilograms. That might be different for you. It told me the velocity of my bus is 10 meters per second. Notice I'm including my units in my substitution. That's part of my rubric also. And I've run out of room, so I'm going to actually take these two and move them over so I can have more room. And let's see. That equals the inertia of the ball. Forgot what that was. 0.142 kilograms. 0.142 kilograms times the velocity of the ball, which is what I don't know. Kind of good to have one thing I don't know in an equation, right? So I would rearrange that. So I have 18,200 kilograms times 10 meters per second. Divide both sides by that 0.142 kilograms because I want to get the velocity of the ball by itself. I want to isolate that, a little bit of algebra there. And now, since I have all numbers on one side, I can nicely pull out my calculator and do, let's see, the top, which would be 18,200 times 10. Divide that by the 0.142. Now, I'm hoping for a number much bigger than 10, right? That's what I said in my Y. Maybe yours said less, so you'd be hoping for a number less, and I get a number much bigger than 10. So I get 1, 2, 8, 1, 6, 9, 0 meters per second. They asked me in the problem to give it in 3 sig figs, right? Express your answer in 3 significant figures to the appropriate units. So I'm going to write it in scientific notation, which you all know. Let's see. 1, 2, 3, 4, 5, 6. All right, 1.28. That's 3 sig figs. The 1 doesn't cause the 8 around, times 10 to the 6th, or millions, meters per second. So 1.28 million meters per second. That's the speed of the baseball. Let's see if it's right. See if it's right. Kathy, you have a question? Yep, exactly. That's the beauty of this. You and I have different numbers, so I can do mine, and you can see my method, and then you still have to go and do yours. Is that cool? Yeah, you can't just copy it down. I love it. So I'm going to put in my answer, 1.28. Now I've got to do that times 10 to the 8. And where that is I use the left-hand button here, x times 10 to the n. So I put that in, and I put 6, and I hit submit, and I got it right. Yay! I love getting them right. All right. So 6.32. The problem asks us about, it says, I've got a 9-gram bullet. Oh, right away I should see grams. Do I like to work with grams? No. What's our base unit? Kilograms. So right away that should send off a little signal in my head. I don't want to work with grams. I got to change that to kilograms almost right away. And has a speed of 110 kilometers per second. Oh, do I like to work with kilometers per second? Meters per second. Meters per second. So the book is throwing 2 little subtle things at me saying, hey, can you convert from grams to kilograms? And can you convert from kilometers per second to meters per second? And then it's throwing at the end, if you look, they're just being nasty with units, kilojoules, when our base unit is joules. So we're going to have to watch ourselves here. What is the kinetic energy of the bullet? Okay. So it would be good to show that you understand what kinetic energy is. Can anyone show me they understand? Like, maybe you guys, you look all done with them. What's kinetic energy? What'd you put for your Y on this one? Energy of motion. Good, good, that's good. I knew you guys knew it. Kinetic energy is energy of motion. What contributes to the kinetic energy? Inertia and speed, right, exactly. Because inertia is how much it doesn't want to move, and speed is how much it's moving. So I would put in here that both speed and inertia control the kinetic energy. And I might put that the bullet has KE since it has inertia and motion. So that's why it has kinetic energy, because it has both of those factors. All right, so right away, they told me it was 9.00 grams. I don't like grams, I want kilograms. So that would be, let's see, go from grams to kilograms. I've got to move it over 3 places. One more. I'm going to do it as 9.00 times 10 to the negative 3 kilograms. Or if you wanted to write that out in decimal, it would be 009. That's a 9 there. And then let's see, what's the other number they give me? 1.1 kilometers per second. 1.10 kilometers per second. We said we wanted to get that in meters per second. So that would be, I want to multiply it by 10 to the third. So 1.10 times 10 to the third meters per second. Or if you don't like scientific notation, 1100 meters per second. Either way works. And good, so I've got those in my base units. Grab my equation for kinetic energy, which is under the words kinetic energy. Convenient, I know. And, oops, that's the one I wanted. Drag that over here. And now we're substituting in again. So we have KE, kinetic energy. Remember, that's one variable. 1/2 is 1/2. The inertia I want in kilograms, so that's 9.00 times 10 to the minus 3 kilograms. My speed is my 1.10 times 10 to the third meters per second squared. I have all numbers on one side. That makes me happy. Then I can use my calculator. So clear that off. Do 0.5 to the 1/2 times 9. This is where I use my EE, what I call the EE key. It's a shift on the apostrophe to give me a lower uppercase E, -3 times 1.1. Use my exponent key again, EE3. You don't want to use times 10 to the caret 3 or something, because that puts it into the calculator as 2 numbers. There it's in as a single number. And that whole number I need to square. So I'm going to square that whole number. If you didn't put it in as one number like I did, you'd have the problem that that squared would only go with the 3. You'd need to put parentheses around it and then square that number. And I get 5,445 joules, which, if you converted to kilojoules, I'd move the decimal place 1, 2, 3 times. So I can write it again as 5.44 kilojoules. Because the 4 shouldn't round up. We'll see if the site likes scientific rounding or mathematical rounding. I'm really not sure which one it takes. Let's see. 5.44. 5.44. Yes. They actually wanted 5.45. They're using, so that's a good thing to know. The site uses mathematical rounding rather than scientific rounding. Good to know. Excellent. All right.